All right. Good morning, good afternoon, and good evening to all of you who have joined us for the Big Data Days, day number 2 on track 2. Today, we are very fortunate to have Mr. Dean Wang as one of our guest speaker. Dean is actually a lead data scientist with Data Robot. He is actually working with the company that provides an AI-powered enterprise platform for data science and operations. Now, Dean has a PhD in operation research from NTU, and he has also worked for the big names like the likes of Google, McKinsey, SAP, Apple as well before he actually joined Data Robot. So today, Dean is going to take us through on the future of machine learning for the masses. Welcome, Dean. Welcome to this session.
Thank you, John. Thank you, everyone. I'm very happy to be here to share my experience with machine learning, in particular, the latest development of automated machine learning.
Wow.
Yeah, as John has said, I have some experience in data science. I get my PhD in operation research. At that time, I don't think machine learning or big data become a subject to study, so I choose the operation research, which is the closest where I can use math to solve real life problems. So I'm fortunate enough to develop my career in data science in the next 10, 20 years. So these are the companies that I have worked with. My first job is with Apple. I was predicting how many iPod they will sell next quarter, next year. Then I joined the SAP. That's where I get my first official title as a data scientist. Then I joined McKinsey, I joined Google, and now I'm with the company Data Robot. So usually people ask, in all my career in all these companies, what is the most interesting project, the data science project I have ever done? Most of them will guess maybe some project in Google, some project in McKinsey. SAP is really a rare guess. I think given it as a German company, it has an image of being solid and deliver in old systems. But actually, my most interesting machine learning and the data science project that I have ever done is with SAP. It is this one. I actually used machine learning to help German soccer team to win the World Cup in 2014. So SAP is a German company. Actually, one of the founders from SAP is actually owning a German football club. So back then, SAP did a lot of sports analytics, especially in the football field. So me, together with my team, were contributing to some initiatives in football analytics. So on this screen, you can see this is exactly the application we built back then. It is a combination of video analytics, real-time analytics, and some prediction to tell the football coach what is happening on the ground, what any decision he need to do. So if you watch the game in 2014, you can see the assistant coach is actually holding an iPad and trying to make sense of the analytics and helping the coach to make decision. So this is the most interesting project, data science project that I have ever done. And as a football fan, although I'm not really a German football team supporter, but I think this is the most interesting data science project that in my career. And I left SAP after the World Cup. So if you are a football fan, you know that in the next two World Cups, German football team actually was knocked out in the group stage. In both World Cups, they were knocked out in the group stage. So I'm not saying there is a causation, but there might be some correlation to the fact that I left SAP and stopped the work for them. Jokes aside, I think this is part of my introduction. I'm very passionate about football. I'm very passionate about machine learning as well. From this project, I have learned three things. The first thing is model doesn't need to be 100% accurate. We need to find a 70% accurate model that works. So this is from the fact that we developed a lot of initiatives with the German football team, from how should they swap the player, substitute the player, how should they play the formation, how should they plan the attack style, and how should they train their players. So there are hundreds of models that were developed for them. We were trying to get most of the model to 100% accurate, if it is possible, as accurate as possible. However, not all the models need to be 100% accurate, and not all the models are useful for them. The most impactful model we have built for the German soccer team is actually an injury prediction model, and the accuracy is about 70-80% at a time. So this is useful because it is very impactful to the actual training, because using this model, they can forecast whether the player is likely to get injured due to non-contact reasons, like not because someone hit them or bump into them, but simply because of too tired. So when we are able to forecast whether the players are too tired to continue with the training, this actually ensures that they always have the best players on the field. So a 70-80% accurate model already created the big impact that helped them to win the World Cup. And second is that the models, AI tools, are only for decision support. Value is eventually created by people. Even in the previous screen, you can see that it is the assistant coach holding the iPad and helping the coach to make decision. So the decision is still with the coach itself. Like AI never make the decision to see how should they play. What is more important is that whatever the model predicts need to be executed by human. So one of the model output was suggesting that in a particular game, it is recommended for the German football team to have their left back speed up 20% in the second half of the game. So me, I play football on my own time, but I have no idea how to control my speed to see 20% faster or slower. So I thought it is a not possible recommendation. But when we put this to the German soccer team, their left back, who is Lam back then, actually delivered almost precisely this strategy. He managed to hold back in the first half and speed up in the second half. And then he assisted 2 goals in the second half. So it is amazing a player can control their body, control the player style like that. But I think that is also evidence saying that model will spit out whatever insight, whatever recommendation from the math point of view. It is still rely on actual people to execute this strategy and make sure the impact is really created. And the last thing that I learned from this is that no model works forever. As you can see, German football team, despite having one of the most advanced model back then, was knocked out from the competition 2 times in a row after that. So I'm not saying that they have been playing badly, but the machine learning or AI just become the new norm in sports as well. Everyone else is also use machine learning and AI in their games, in their trainings. The competition advantage is not there. Unless German soccer team keep on retraining their model, keep on developing new use cases, the advantage that brought by AI and analytics will be gone sooner than they think. Also, even when they have the best model back then, the model will change because people will react differently to the model. This is what we call concept drift or data drift. When the training data you use to train the model is different from the actual application data you want to use a model, you need to retrain. You need to be aware of this change and retrain the model. So no model works forever. We need to know when and where the model stops working. So these are my key learnings from my most interesting data science project. And it seems like a little bit not relevant to AutoML, but we will come back to this. I think this is actually my motivation. One, I believe that automated machine learning is the way to go because it will help us to address all these 3 learnings I'm mentioning now. Okay, so let's take a step back. We all know AI is useful. I think the fact that you are spending your morning, your afternoon, or next 90 minutes, hopefully 2 hours with me here, is because you are interested in AI and you have the belief that AI can help people to do other things. So we know that AI is used to automate other tasks. What I'm showing here is actually a video of a game called Brick. I guess most of us may have played this when we were young. So this is a deep learning neural network trained to play this game. So this is after 100 training. This is after 200 training. You can see the AI seems to understand it's supposed to get the ball and bounce it back. After 400 training, it becomes pretty good. It is difficult to see the ball fall off the board and stop the game. Let's see what happens next. After 600 games, AI discovered this technique called the tunneling. It can put the ball to the upper level and just let them bounce. So this is what we hope AI can do, right? We can train AI to do some task, to learn from the human way of doing the task. Then hopefully AI can learn and invent their own way of doing it even better. So AI is used to automate other tasks. And we have all these kind of dreams and ideas what can be used, or where AI can be used. You can use it to play a game. You can use it to select the customer you want to serve. You can use it to write email, like using ChatGPT, or you can use it to automate a lot of like tasks that you don't want to spend time on. However, for us to address all these kind of ideas, we can't build AI one by one. We need some help to automate AI. Meaning that, can we automatically generate AI solutions with a minimum guidance, with a minimum requirement, so that we can capture value from AI? This is what I want to talk about today. What do we mean by automate AI, and what needed to be done for us to automate it? I'm from DataRobot. Our company's mission is to democratize AI and help you to automate AI. So I will use our company's product as an example to show like how automated AI looks like. There are other solutions in the market. All big companies are working automated AI. They have different rendition of this concept. So feel free to explore. But for this presentation, I will use DataRobot's example as a automated AI platform. Before I started to go into the content, let me ask you something. Can you share your experience with AI with all these reactions? If you are new to automated machine learning, please give me this this love it reaction. If you have tried AutoML, not a regular user, give me a super. If you heavily use AutoML on a regular basis, share with me a clap. I think you can select the reactions underneath the screen. Yeah, I see some frequent users of AutoML. Some of you are new to automated machine learning.
I think quite a number of people are new to the machine learning, Dean. So I think you might have to go slow a little bit.
Sure. I will try to cover the basics as well. Okay, so let's take it from the beginning. So what do we do with legacy machine learning? Machine learning is basically to derive predictions from data, right? In legacy machine learning, or the way that I learned machine learning, that we need to write a lot of code. First of all, a lot of code need to be written to wrangle the data. I may need to use Spark, I may need to use SQL to connect the databases, to find the relationship among the databases, then to prepare a data set for machine learning. Then I need to continue to write more codes as a prediction algorithm, either using Python or R. I need to build the algorithm. Most likely, I will leverage some existing package that contains the algorithm that developed by some experts. and I leverage the algorithm to make the prediction. And hopefully this pipeline that I built by stitching the code together works either in the experimental environment or in the production environment. But there's more than that, right? Like if I only have these pieces of code, it's difficult for any non-technical people to use it. So I had to learn some visualization scripting tools, either JavaScript or CSS, to really wrap up this application as a software or as a website so other people can use it. So this is legacy machine learning, when you need to create the pipeline from scratch and you need to stitch the codes together. Then we have a canvas-based machine learning. Maybe some of you used this kind of tools. There are tools in the market that help you to build a pipeline without coding. What you need to do is you need to drag and drop this kind of functional modules to a pipeline to create a machine learning pipeline. So for example, you may want to use this module to cut some data or to separate the data from, to create partitions in the data. You may want to do further like wrangling of the data or cleaning of the data. And then eventually you need to drag in a module that representing the algorithm to make the prediction. So this is a canvas-based AI platform where the user is responsible to drag and drop and create the pipeline. It seems to be one step ahead, right? Like we don't really need to code everything, but to really use this kind of tool, one still need to have a good understanding of whatever the module is doing, because you are responsible to come up with this pipeline and stitch them together. So if I'm going to create this pipeline, I need to know exactly what does this module do, what is the input and output, and how does the output fit in the next module. So technical understanding is still required. It's just that I don't need to spend that much time in coding. So I think this is one step further to take AI to the general masses who may not be an expert in coding. But what does automated machine learning really look like? So maybe this is our wish, right? If we really want to automate machine learning, it means that I only need to tell the platform what is the data I have, what is the target I want to predict. Then I click a start button. The entire pipeline is generated automatically. So this is the automated machine learning that we want to deliver. The automated machine learning experience we want everyone to be able to enjoy. Not only it removes the hurdle of coding, we leverage the experience of other data scientists to automatically generate this pipeline for you. So no matter it is prepare the data for modeling or eventual prediction, so this entire pipeline can be automated and generated for you. So this is our vision of automated machine learning. I will break this down to different parts in today's session, but keep in mind, this is the automated machine learning concept that I want to talk about. By the way, if you have any questions or at any point you feel like to discuss, feel free to drop your questions in the chat or simply raise up your hand. So I guess John and John will let me know if there's any question there, and I'm happy to discuss in real time as well. I think there's not a lot of people in the session. I would rather make this as a fireside chat or intimate session that we can freely discuss rather than that lecture or tutorial that I keep on talking. Okay, so feel free to ask me any questions or give me any feedback during this. Okay, so this is the concept of automated machine learning today. As I said, I will break it down to different parts so that we can zoom into different parts of the machine learning tasks. But generally, when we talk about machine learning, it's three things, right? Like when I try to become a data scientist, I know that I need to be an expert in data, meaning that I need to know how to wrangle data. I need to know how to write code to process data. And second, I need to be an expert in the algorithms. I need to understand what are the predictive algorithms, or what are the what are the and what are the algorithm, what are the things that I need to train, how to code in Python, how to code in R. And of course, there's also the business understanding, that the domain expertise. If I'm working with some telco, I'd better know what does it mean to say churning or churners, or what is ARPU, what are the objectives of any business problems. So as a data scientist, we always want to have these 3 dimensions. I think this is a perfect time to answer the questions in the chat as well. In legacy machine learning, or as a data scientist trained 10 years ago, I need to be aware of all these 3 dimensions. Like, I need to train myself with data skills, with algorithm skills, and I need to be exposed to the business problems enough so I have the business acumen to answer business questions. However, with AutoML, what we are trying to do is to lower the hurdle on the data and algorithm side, meaning that we hope with automated machine learning, you don't have to really understand so much about the scripting language. You don't need to really understand all the algorithms, how they are doing. What you need to do is to relate your business challenges to a machine learning problem and leave the development work, leave the coding work to this automated platform, so that you can get the output, and you will be the one to see whether this automated algorithm actually create business value for you. So that is what we want to achieve with our automated machine learning. So to answer the question, I think automated machine learning will definitely have a much lower requirement on the hard skills in terms of math and computer science, but so that the user can be more focused on creating business value or solving business problems using the tool. We call this value-driven AI. So everything can be start from the business value and anchored back to the value itself. So it's not as simple as 3 dimensions, right? If we look at the actual machine learning process, at each of the dimension, there's a lot of tasks you need to do. Like in data, you need to collect the data, you need to ensure good quality of data, then you need to prepare the data for machine learning. Then for the algorithm, you need to formulate the problem into a machine learning solvable problem. You need to build up the pipeline, tune the model, and eventually select which are the model that is good to use. On the business side, whatever model you have built here, it is only your lab test, right? Like you build it in a lab environment. If you want to create business value, you would need to bring this model into a production environment. This is what we call deployment. Then you need to create application around it so that users can really use it rather than key in their number and see what happens. Maybe you want to integrate your model into your production line. Maybe you want to expose your model to the frontline users who actually have the data input. And eventually, you may consider when and where do you want to retrain the model. So this is a life cycle of the machine learning development. What makes it more complex is that it is not always a linear process. So you can go from one step and jump back to another step. For example, maybe you have gone through the data collection phase. You feel like you have all the good data you can collect. But when you formulate the problem, you realize that the data is not good enough, or it doesn't capture the insight you want to have in this machine learning problem. That is when you need to go back to collection again and go through the cycle. Similarly, it could be like even when you tune in the model, you find out that a lot of noise in the data that downgraded the model performance. So you want to go back and check the data quality again. So machine learning lifecycle, although I put it like as a simple way like this, but it is never a linear or circular way to deliver. You may jump one step to a different step at any time. So that means that if we really want to automate this, and if we really want to make non-technical people or the masses able to solve this, we need to make sure all these are flexible for them to explore. and we also need to address the full cycle of the machine learning development. So I think this is a scope of AutoML. If we really want to automate machine learning, we would need to automate almost everything in this life cycle and make it flexible to jump from one to another. That is why when we talk about AutoML, although there are like solutions, like open source solutions provided in the community, I think it is still a much better way to use a platform to solve it. Because if AutoML is not about you automate a particular fraction of this process. If you really want to create value and democratize AI, you need to automate almost everything here so that it is really exposed to the normal people or the masses. If you only automate model tuning or the pipeline, normal people will not have the good enough skill to prepare the data by themselves and feed into this one, or they would not have the skill. Even I don't really have the full IT skill to see how do I deploy a model from the testing environment to the production. So if you only automate a part of this, it will be quite challenging for people to understand. Okay, so for the remainder of the session, I think I started by what I want to do now is I want to elaborate the scope and the concept of AutoML so that you guys understand what we will be talking about today. I will try to make the rest of the session as layman understandable as possible. So I will try to explain what are the easy questions that we see, or I will try to put the presentation in a simpler format.
Dean, there is a question in the Q&A.
Yeah.
You seen that?
So
yeah, so I'll just project it out. So it says here, it's actually from Anonymous.
Yeah.
So from the way that you have explained, it is quite technical. I am a non-techie person. How difficult it is for a non-techie person to pick up the skill that you mentioned that we needed to automate all the different areas, right? I think in the previous slides. Yeah, I think this is actually a very comprehensive data science kind of a way of doing things, right? The life cycle of the project itself, right? So how do we actually go about it if I'm not being technical to help our audience out?
Sure. So sorry, this seems to be a little bit overwhelming with all the different tasks and make it complex. So my point is that if you want to be trained to be someone who can do this full cycle machine learning development, it will be a very technical job, and only technical people can do that. But the fact that we are trying to automate all this is to lower the bar of technicality so that normal people, even non-technical people, can do that. So in the next 1 hour or so, what I will try to do is to explain from the data perspective, algorithm perspective, business perspective, how AutoML is helping you to bridge the gap between the high standard of requirement of running such a pipeline to the low requirement of like normal user who want to build a machine learning platform. So that's exactly where I will be, what I'll be talking about in the next 60 to 90 minutes. Cool. So this will be my structure. I will try to talk about data, algorithm, and business, and what the AutoML means in these dimensions. Let's look at the data first. So, okay, so this is data, right? When we have a data and when we want to examine the data quality, I think even a non-technical people may understand this. Like we always try to understand what is the average of all the data or what is the standard deviation. And if there are two dimensions, we want to understand the correlation of them. Is this good enough to describe the data you have? Well, it is good in the sense that at least we have some statistics. We try to understand the data, right? But what is funny is that all this data shown on this graph have the same statistical property on the right-hand side. So if we only look at this kind of technical statistics, you can't really make good sense of the data. So I don't think you need like technical skills to really understand what do I mean here, right? Like the statistics is important, but it doesn't really tell the full story. It can be anything on the left-hand side, and this may be much more interesting than the statistic itself. So what do we do here? To ensure data quality, the easiest way is to visualize your data. But again, if you ask a data scientist to create this kind of visualization, it will take a lot of time, a lot of coding to do that. So this is the first gap maybe AutoML or any AutoML platform would want to address, which is how can I visualize the data so that I know the data, the distribution or the layout of the data is something that I can use. So let me show you what does this mean on a real product. So on Data Robot platform, we do this kind of data quality assessment automatically. So all these quality issues of the data can be detected automatically. You don't have to understand how do we calculate, let's say, outliers, or how do we find out excessive zeros. Data Robot will try to find this for you. Moreover, all this statistics is automatically calculated for you, and all these distributions or visualizations are created. So I think this is a very simple example. What do I mean by bridging the gap, right? You want to understand the data quality. You are not able to create this visualization. So the tool help you to do that. So this is what Data Robot or any AutoML platform tries to do to bridge the gap. Of course, this is only a numerical data. Let's say if you have more complex data, in this case, you have geometry data, which is defined by the zip code. We can visualize it on a map. And if you have image data, we can also show them to you. So all this data will be verified automatically that it is of good quality to be used in machine learning. So I think this is the first step of all the machine learning tasks anyone need to do. And I use this as an example to show what do I mean by AutoML is trying to bridge the gaps. And of course, there are other things that we may want to do, right? Take this example here. If you have a date field, let's say if you have a date field in the data set, do you want to break it down to month, day, year? Do you want to do it on your own, or you want the tool to do it? I think if this can be automated, of course we want to automate it. If there are missing value or transformation needed in the data, do you want to do it yourself, or do you want to automate it? Of course you want to automate it. If there's a domain knowledge or subject matter that involve in this data, how do you want to get guidance, or how do you understand if the data is right to use? I will suggest you to talk to the domain expert. So these are the two sides of data quality we talk about. Data quality can be always a mathematical topic, whether the data quality is good, whether there are enough information in the data. It can also be a business topic, which relates to the definition of the data or the logic behind the data. So what AutoML is trying to do, as I said, is to patch up the data side of things, the math side of things, so that you don't need to worry about the math, but you can focus on the business side. So in this case, in data quality, we will leverage the algorithms or the math we know to ensure that mathematically the quality is good enough. But you would be responsible to see, like, business-wise, does this data capture the enough information you want to have? So again, I see the question here. is there a way to ensure data is fully accurate, or is there some guarantee provided? So my question here is that how do we know if the data is fully accurate? Or do we really have fully accurate data? I don't think we really have the fully accurate data ever, right? Like I have never worked in a data set that is perfectly accurate or perfectly good to use. So we need to make sure mathematically the quality is good, not a lot of missing data, not a lot of information that will downgrade the quality of our analysis. But it is still the business owner or the user need to be sure that the data is a real reflection to whatever is measured, or it's good quality in the business sense. So take an example. Let's say if we are doing some predictive maintenance, I will use a lot of sensor data in measuring the machine status. Data robot sees that, okay, all the signal comes in, it seems to be valid, the distribution looks nice. Mathematically, it can be a good data. However, if we understand how the machine works, it could be like some sensor is not even working, it just put out the default value or random value. It just happens that distribution looks nice. So this kind of check relies on human to do that, to verify that the data collection process makes sense. If anyone who manages the data can be sure that the data collection process makes sense and is secured, the math or the math part can be automated by the AutoML platform. So that's how we see the problem, right? You may see this continuous in the next parts of this presentation as well. When we say we automate AutoML, we automate the data part and the algorithm part. For the business part, we provide enough information so that human can make their decisions based on that. We believe this is the best way for human to work with AI. We are just like the thing I mentioned in the football example. The AI never makes a decision by itself. We make sure that we have enough information, we provide enough information for the coach to make the decision. In this case, you guys would be the coach, and the data robot or any AutoML platform would be the platform that gives you the insight, give you the opportunity to verify the data, the insight actually makes sense. So hopefully this answers the question. Okay, let's move on. After the data quality is good, we also need to prepare data for machine learning. So what do I mean is that machine learning is a process of wrangling data, right? So in a very simple case, if we deal with tabular data, this will be the input of machine learning algorithm. For those who are non-technical, so this will be a very simple explanation of how machine learning works. So if you are new to machine learning, so maybe this is an explanation to you how machine learning works, and then we'll look at how automated machine learning can do different parts of it. When we have the data like this, we can say all the columns are the variables we'll use, and all the rows are the samples we want to predict. So let's simplify it and understand it in this way. What happens in machine learning is that we will define a target variable, which is a variable that we want to predict. If you want to predict how much product you will sell every week, like what I did in Apple, the target variable would be the amount sold for that product every week. So every row we may have a weekly record, and the target variable on each row would be the amount of units sold that week. The row variable would be the other information we believe relevant to this sale. For example, again, if we are predicting how much unit we are selling each week, the row variable may include what is that week, the date, the starting date of the week, whether it is a holiday, how many staff you have in the shop that sells the stuff, and how long hour you are opening. So all these raw variables would be the raw record or the numbers we collected as variables to predict the target variable. However, usually this kind of raw variable would not be good enough or more or simply enough in quantity to make the prediction. What we need to do is we need to derive the variable, new variables to form the features. So in this case, if we have the date as a raw variable, the derived variable could be whether this is a Monday, Tuesday, or holiday in the calendar. So we can derive information from the raw variable. Similarly, it can be, let's say, the difference between two variables become a new variable. So this is a way we derive a variable and create what we call features. So features in a machine learning model are the variables that we use to predict the target variable. So now we have the target, which is our objective, and we have all the features. What we want to know is that how can we use this kind of variable to predict that? But before that, to make sure our model is valid, we need to do one thing. It is to separate the data as training data and the testing data. Because when you train a machine learning model, you always want to train it on a subset of your data you have. In all this data, you already know the target variable. So training this data does not really create any value for you. However, even when you train it, you do not want to expose all your data. This is like when you take an exam, right? You want to prepare yourself, you need to train yourself with the exercise enough, and you want to take a mock test before you go to the final exam. So all this training data are the exercise we ask the model to do to train the model. And the testing data is like the mock test. We want to know if the model is performing well on this data set. So you need to separate the data into training and testing. And then you can build a model to predict the target variable with all these features you have. When all this is done, you can use your model on a real data. That means all the patterns you have found in the training and the testing data will be applied on the real data so that the real predicted target can be calculated. So this is how data is used in machine learning. We will need to first expand the data to derive the features. Then we separate the data to training and testing. We use a model to find the patterns to predict, and eventually we use the model on real data to predict the target variable. So when we want to automate this, we would want every part to be automated, right? We would want some automated platform can help me to create the variable, to train the model, to separate the training and the testing, and eventually to make the prediction. What data robot does, or what automated platform does, is for you to set up this kind of relationship and define the target variable, define the feature discovery. So let me show you an example on the platform again. So here I'm using an example of a house pricing. Let's say we want to predict the price of the different houses. In this main data set, we have all the information about the house. You can see this, including like which year it is built, how many floors that it have, which area it is in, all this kind of information. And we set target as a price. So these are our raw features. We want to use these variables to predict the price of the house. However, is this data set good enough to use? Maybe, but we can always have more information, right? Now I have 3 more data sets. First of all, I have the geospatial data, meaning that I know where these houses are. I also have the images of the data, like I showed just now. We can link the image to these houses. And eventually, we have the historical listing of the other houses in the region. So this would be a very interesting data set, right? If I know how much we sold a neighbor house, maybe it will be a good insight when we predict the price for the actual house. So in legacy machine learning, when I need to consider all this information in, I will need to join the data myself, meaning that I will find a way to link one record in the main data set to some records here. Especially when we talk about history, it is always tricky because I don't know how far ahead or how far behind I need to look at the history, whether I need to look at the 3 years history, 5 years history, or 10 years history. So that is subject to experiment. On this platform, what we can do is basically drag and drop and define the relationships. So what you can see here, what I have done is that from the primary data set, I have asked this platform to look at the geospatial data mapped by the listing ID. So in this geospatial data, I have all the listed house and the geospatial information. So by mapping them, I can actually look over this new data set and find if there's new information relevant to the price of the house. I can also look at the images of this house. And for the listing, I can link it by the elementary, which is the area of the house, as well as the date of sold. So you can see I defined 3 time window here. I'm asking this platform to check whether 30 years before the sold date, or 3 years before the sold date, or 2 weeks before the sold date is relevant for the prediction. What this platform will do is it will do all this kind of transformation. It will calculate if it is a date field, it will calculate all this data information. If it is a numeric variable, it will calculate all this numerical information. If it is categoric one, it will summarize all these categories so that I can calculate new features that help me to do this prediction. So this is another example of automation. If you want to do it manually, first of all, you need to know SQL, you need to know the data preparation script. How do you do that? Second, you need to spend time to write down the code and experiment which time window actually gives you the best value. And you need to repeat this for multiple time windows until you are happy with one of them. So what I have done here is I remove all this coding and the mathematics related stuff. And what you need to do is to leverage your business understanding to see how the data links to each other. What is the relationship among the data set so I can use it in a machine learning? Again, this is another example. How do we remove the technicality in machine learning and help you to focus on the business side of things? So this is how we set up this kind of model. If I switch to the same model that I run using this, you can see these are the data derived from the new data set. So this would be the data eventually used by the model. Some of them without any bracket are the raw data, but all this data with square bracket or flower bracket is actually the derived data that's from new data set. It could be a little bit complex, but you can see all this combination and merging is automatically done by the platform. I only defined the relationship, and this platform actually go into the data set and find out the 1 year average of the square feet sold in this area will contribute to the prediction we want to make. And because of this is a feature that is used in the model. So this is how data preparation or feature generation is actually automated in machine learning. And it goes beyond this, right? Like if we only talk about data, of course, you need to connect your data into different platforms. You need to consider all different types of data. Just now we see that we need to deal with tabular data. There are image data, there are geospatial data. What we haven't shown is that there could also be time series data and the text data. So all these types of data need to be ingested. Your platform or whatever you do in machine learning could be on different kind of platforms. It can be any of these cloud providers. It can be your private cloud. it can be your VPC, and eventually you want to consume the machine learning information on all these kind of intelligence applications. So when we talk about prepared data or data connectivity, it is not only how you get the data from your data sources, but also how do you adapt to different types of data? How do you make sure your algorithm runs on different infrastructure and that the output data can be fed into all these applications? This is why this reinforces my point, right? Although there are open source packages can do certain part of AutoML, it is actually much more easier to use an industrial level platform to do this kind of automation, because there are so many considerations you need to put into this one. The way automated platform to do that is that, first of all, there will be pre-built connections. So all these data connections can be pre-built in the platform. It makes it easy for you to connect to all these data sources. And in most general source, if you support like a JDBC, I think most of the platforms can connect to that. The second approach of AutoML platform is we containerize the algorithm or the codes. So the code can be run in different environments that is predefined. So as long as we build the code for you, you can actually run this code in different environment and in different infrastructure. Later, I will talk about deployment. It is the same concept, how you mobilize your code, mobilize your program so they can run in different type of environment. And eventually, we provide different APIs, interfaces, so that the result or the model itself can be interfaced with other applications. So this is how automated ML platform address this kind of connections and environmental changes. So to summarize this part for data, we automate the data quality check for all types of data. We automate the data discovery and generate new features. You only need to define the relationship between the data sets, and the AutoML platform will look across to find the new features for you. And finally, we automate data connections and integrate with the other parts of your system. So I think this is the data part of AutoML. And it may already sound a little bit overwhelming, right? Because we want to do so many things. But again, the platform itself, the technology itself, is removing the coding part, the math part out of the picture. You only need to focus on your business understanding to see what are the data you need, how do you define the relationship, and what kind of output you want to have in your pipeline. Then the platform can be configured in a way to help you to solve all this. Okay, so let's move on to look at the algorithms. It may be, normally this will be the most technical part, but hopefully when we talk about AutoML, it is simplified. So I think the first challenge in developing a machine learning algorithm is that there's no single way to formulate the problem. If we look at a predictive maintenance problem, there are so many ways to solve it, right? Predictive maintenance is basically you want to predict when a machine part will fail or broken. It can be a regression problem. Let's say you want to estimate how much more time this machine parts can still be used. So it becomes a regression problem because the objective is to find out the continuous variable that describes the remaining time of usage. It can also be a classification problem because you can classify it in a way that whether the machine part will fail next week or not. You don't care which day next week the machine part fails. As long as it fails next week, it matters to you. So you can do it as a classification problem to see whether it will fail in a time window. It can also be a time series problem because you want to see how the machine parts performs over time. Maybe some of the ups and downs will indicate certain failure or certain issue with the machine part. It can also be unsupervised learning, where anomaly detection or clustering may be used. Anomaly detection is that when you present the data to the algorithm will try to pick out those who stands out, who is different from each other. So sometimes in predictive maintenance, the failure or the issue with the machine cannot be defined. Like people would not know when the issue start to happen. So we will rely on this kind of anomaly detection to look into the data and find out any anomaly in the data set itself. And eventually you may use it as a clustering because there may be different patterns of failure, different parts of the failure, or different segments of the failure. You want to group them together. So even for one use case or one question, you have so many ways to formulate the problem. If we want to automate machine learning, it means that we need to accommodate all these kinds of options. So again, let me switch back to the platform. What you can see is that we try to automate all this. Here in this data set, I'm simulating a use case of predictive maintenance. Let's say these are the description to the machine parts. If we want to predict whether the machine is broken and use it as a target variable, you can say here, the platform already recognizes it as a binary classification because the value I selected as target is only 0 and 1. So it will be recognized as a classification and trying to do it. But if we change the problem formulation and we selected lifetime as a target, since this is a continuous variable, right? This is actually brokenness binary and the lifetime is actually a continuous variable. This becomes a regression problem. So the platform already know to find out this target, it will try to run a different set of algorithms that gives you the answer. And if, let's say, as I said, when we don't have any target variable, I will turn on unsupervised learning so that they can look at anomaly detection or clustering in the data set. In this case, since there's no target variable required, I can basically click the start button and the algorithm will try to pick out those irregularity or issues from the data. So this is what we call so this is how we automate this problem formulation part. The platform is flexible enough to recognize different setups of the formulation so that you can experiment various approaches to this one. In machine learning, I think one key learning that I have in machine learning is that even for the same problem, even for the one question repeatedly asked, there can be tons of solutions to that. So trying to do more experiment and trying more different approaches is always a good practice here. And then when we define the problem, we need to build the model and fine-tune the model. I think this is the interesting part because not only like non-technical people want to use our platform, right? Data scientists may also leverage AutoML to speed up their work. So a machine learning platform need to cope with this spectrum of coding. There may be data scientist who is comfortable with like Python R code to have a full code experience. There could also be non-technical people with no coding experience and do not want to use any of the code. So what we are trying to offer as an AutoML platform is that we can do full code model building if you leverage these Python and R APIs. And if you want to do collaborative building, we have integrated notebook with code snippet. Actually, the latest one, you can use something like a Copilot to write the code for you, right? So you are collaborating with AI to write the code. And if you want to do even lower code, we auto-generate a lot of scripts. So whatever you need to do is to change the key in this kind of code to use them. And even if this is, again, like too much, as I shown just now, it is actually a web-based UI that no code is involved. you only need to click the start button to build the model. So I think for an AutoML platform, the way we design this platform is that we want to address this wide spectrum of coding, from full code to no code, to make sure anyone with any preference can use this to build their machine learning model. Then the next step would be model selection. I think this becomes the interesting part. Even when we automate all this kind of thing, like model building, click the start button, this part, when you select the model, is where your business insight actually matters. Because a model performance can be a technical performance measured by the technical metric. Again, this will be the math side of machine learning. All these metrics are calculated math results. So if you want to know more about this kind of metrics, you can always go to, like, we provide this kind of documentation to explain what is log loss, what does log loss mean, or what does any of this kind of metric mean. All these are automated because these are the math side of things. We calculate all this for you. However, when we select the model, it may not always be the technical metrics that matters. Sometimes it will be the business metrics that matters. So that's why we also provide this kind of visualization and function for you to evaluate your business insight. In this example, I think this is a same predictive maintenance example. So basically, I'm doing a classification problem to want to predict how whether the machine part will fail next week or so. Every machine learning model makes mistakes, right? Like you can see here. Sometimes I make the right prediction. When the actual is false, I predict as false. So this is a true negative. When the actual is true, I predict as true. This is true positive. So these are the correct guesses I have from the model. However, there are also false positives and false negatives. For false positive, it means that the machine part actually failed next week, but I predict as not failing. False positive means that I predicted that the machine will fail next week, but actually it won't fail. So we have all these types of performance metrics. As you can see, after you build a model, you can change the threshold of the model, meaning that the way you classify as true and false, all these metrics will change. Some of the threshold will lead to a good true positive, but a very bad false positives. So how do we define it is a good model? Of course, if it is only from the mathematics point of view, again, we automate this kind of mathematical calculation for you to see if you want to optimize on a mathematical metric, what is the optimal setup. However, this is not really the business optimal, right? Let's say in this case, when you have a false negative, which means that the machine is actually failing next week, but I predict as not failing. It will cost you some money, right? It means that the machine failed out of expectation. You may need to shut down your entire production line because of that. So the cost of this kind of mistake could be a lot. However, if you predict it to be fail, but if you predicted it to be failing, but it actually do not fail, it means that you may ask your maintenance engineer to swap the parts to stop it from failing. You wasted a spare parts, but compared to the cost of shut down the entire production line, it may not be that significant, right? So the cost of the false positive and false negative could be different. Similarly, the reward of true positive and true negatives could be different as well. In each of these prediction results, your business value could be different. If we consider all this, we can actually evaluate the profit that I generated from this model. considering all the correct and incorrect result. So the model now can be optimized to maximize the profit. And we can give you the best model setting that optimize for your profit. So this is how we, again, try to remove the hurdle in data science and math and help you focus on the business insight. Other than this, I think the other side of the machine learning insight, including like how do you understand the features, right? So we can also present to you what are the important factors that are involved in this prediction. So the business owner can use this to verify them. One way that some of my clients do is that when they look at this kind of list, they will immediately think, of course, the first one, and based on their domain knowledge, apparently this is the most significant predictive feature. So it is right to have it here. That is a good thing, although this is something they already know, but I think having this feature on top of the list actually shows that the model echoes their domain expertise. Then when they look down, they say, okay, this is interesting. I never thought of this feature can be predictive as well. So this will generate new ideas for the business user, for the domain experts to look into the problem and maybe find new insights. They can even look at feature-wise impact to see where does this feature change. As you can see, this one, although it is generally a very negative correlation, but we can see the rate of negativity is different. So maybe something happens here could be interesting as well. Similar thing to this feature. Although it is generally a positive thing, but you can see it increases much faster in this lower range, and you kind of have this step jump here. So these are the things the business expert would want to leverage machine learning to find out and understand how does this impact their machine learning. Okay, so I think this is how machine learning, when you select a model, how the automated platform can help both your business user and your technical user to make use of your model to understand it. And another thing about automation is that because all the coding part and the math part is automated, it supports you to do rapid experiments. In machine learning, there's always a lot of experiment you want to do. No matter how you set up the model, there's always an alternative way to do that. What I'm showing here is when you analyze the time series there are multiple windows you may want to play around and do tests. For example, this is the blue line is actually the feature derivation window. It is the length of the past data you want to look back to predict the future. For example, if I want to predict the weather of next week, maybe I will consider last 5 weeks temperature or raindrop rate to forecast the weather. I can also consider the last 5 years history to see what is the weather like next week. So you can actually select a different history window to derive the feature. One thing that you need to experiment here is it is not always the longer the better. When you have an extremely long history to predict the future, it may not give you the best result in terms of prediction. So you need to test how to set this feature derivation window or historical window to a proper length so that the prediction is accurate. Similarly, you can also set up the forecasting time window. You can either forecast 1 day in advance or 7 days in advance, or you want to predict the 7 prediction points on each day for the next week. So the way you set up this model, of course, is coming from your business understanding, what prediction you need. But you need to experiment the combination of the forecasting window and the feature derivation window to see which one gives you the best result you can use in decision making. More than that, there's also a gap in here. We call this the action time window. Because let's say I want to predict something next week. I do not have any data for this week. all the data I have is from previous week, right? That makes the current week a gap between history and future. I cannot use any data in this week to do anything because the data hasn't been collected, but I need to predict next week already. So that's why you have this kind of gap between the feature derivation window and the forecasting window. So this is how do you want to set up a machine learning model? But all this setup, although the automated platform can recommend something, it may not be the optimal for you. You will need to rapidly experiment this. Rapid or experiment in legacy machine learning means that you need to rerun the code. You need to tune all the code that you write for the experiment for the next experiment you have. But when it is automated, what the platform can do is we can generate tens or even hundreds of models for you in one go. So in this platform, after you click the start button, we will try to generate a lot of blueprints or algorithms for you. Each of them is actually a combination of all the data pre-processing steps together with a prediction algorithm. As you can see in this project, I have automatically generated 56 algorithms. So this helps you to experiment fast. Not only you are experimenting with one problem setup and with one algorithm, you are experimenting one problem setup with 56 models, and all these are built within a couple of hours. So imagine the speed that we can bring this to, how rapid it is. You can test the different hypotheses overnight, and the next day you may have a good way to go to see what is the actual approach you need to have. So this is about algorithms in AutoML platform. We need to automate all modeling types, including supervised, unsupervised, or time series, as I shown just now. We need to automate model evaluation and selection. We need to consider both technical metrics and business metrics. And finally, we need to support automated experiments. It has to be rapid and it has to be at scale. I see there are two questions in this panel, like coding restrict complex models. So again, for this question, so the question is that if there's a lack of coding skills, does it restrict the complexity models data robot users can use compared to people with more advanced coding ability? Again, our purpose is to remove the hurdle, right? I think we can set up the baseline for non-coding based user to quite high. After click the start button, all these are generated for you. So all this kind of pipeline or blueprint may need, even for an experienced coding expert, it may take them a couple of weeks to complete. But with this kind of automation, you can do it in a couple of hours. So we bring up the baseline of what you can achieve as a non-coder to pretty high. However, let's say if you are an experienced data scientist, you want to do more advanced thing, we support you to do that. As you can see, there's advanced tuning. So you can actually further tune the model, try to get a better performance. When we automatically generate all this pipeline, an experienced coder can still continue to customize all these tasks in this blueprint, or even bring in their own algorithm as part of this pipeline and train the model and compare. So we are trying to help both code-based or non-code-based data analyst, data scientist to solve the same problem. If you know coding, if you know like additional things about machine learning, you can even lift this baseline to a higher standard. But if you do not know coding, you are already on a pretty high baseline that the automated thing can help for you. And the next question is that offer criterion basis. Yes. So basically this, I think the criterion of false negative, false positive comes from your business understanding, right? The best way to use this kind of thing is to sit with your business stakeholder so that they understand what happens behind the magic. The machine learning is no longer a black box for them. They can have certain control on how do we design and even build a platform. Okay, so this is about the algorithm side of things. The last bit of it is business. So as I said, the first thing we want to solve in business is that whatever you build just now, any algorithm or any solution you build from the data is built in a lab environment, meaning that you build in a controlled environment with all the data to be ready for you. You need to move into operation for people to really use it. So there are three aspects of that. First of all, you need to serve the model, meaning that when you build the model, you collect the data by yourself. You try to make sure the data connection is built, and you try to grab the data to do that, right? But when you operate the model, the data need to be fed in automatically, and the prediction need to be generated automatically as well. So this is what we call serving a model. In my experience, it's actually very challenging for me to move my model from a pilot or proof of concept to operation. I built a lot of like proof of concept models in McKinsey. I think it is correct to say all my model I built in McKinsey stopped as a proof of concept. We didn't manage to move into operation because operating the model is a totally different game. When you build a model, you talk with the data scientist, you talk with the business owner to make sure the model is accurate enough, have enough business insight. When you try to serve the model, you need to talk to your IT people. You need to find an environment in your IT system that help you to serve the model. So it's a very different conversation you will have. In Data Robot, we try to help you to do this as well. You can see we have this one button deployment, which brings your model. Remember just now I said that all the model that is automatically built is actually encapsulated within a container. So when you set up a deployment, we're actually moving this container from the experiment environment to the production environment. So you can see if I want to deploy the model right now, I can select what are the prediction environment I want to have. It can either be a cloud environment, it can also be an on-prem environment. So you don't have to configure this kind of environment because all this configuration, again, is automated. You only need to decide which model do you feel is the most valuable to be brought into production. Then you can deploy the model automatically. Once this is deployed, it will bring you to such a dashboard to show the different aspects of model operations here. So one thing I have shown just now is serving the model, right? So it is related to the service health of the model. So this is a dashboard. Maybe I show a different model that, let me just use this one. So this is basically a dashboard telling you for this particular model, how many predictions are you making? How many requests are you making? If the response time is wrong, if the execution time is wrong. So this is a very operational view of your model in production. Whether they can get enough data from that, from the sources, whether they are making the predictions in time, whether there's any issue with the configuration of the data connections. So all this help you to monitor the serving of your model. This is automated as well. But it is more than that. We also want to monitor the model and retrain the model. So let me again show it here. Monitor means that we want to see whether the model is performing well. There are two aspects of that. One is the accuracy. Let's say if you manage to collect the actual outcome of your decision, you can compare this actual value with the predicted value, and then you know whether it is an accurate prediction or not. So when you set this up, let me you can see some of this model would have a good accuracy, which means that the model is always performance within certain threshold. For this model, my accuracy or the error rate actually increased over time. That is why I have a notification here for me to look at the log loss have exceeded the threshold. So it may need to be taken care of. And this accuracy is basically the performance of the model. What we also watch is something called drift. Drift is an interesting behavior of the data. That is when the data you use to score or you use in action becomes different from the data you use to train that. Think of COVID. Let's say if someone trained a model to predict how many people goes out to do exercise. Maybe that is a good model before COVID. What if COVID happens? During COVID, this model will be no use, right? Because the situation has drifted away from the concept you trained the model on. So you need to monitor this kind of data drift, because once the data has drifted away, you will not be able to make good predictions. If we in legacy machine learning, you will need to assign someone to look at the distribution of this incoming data and see if it is the same as the training data. Again, a modern automated machine learning platform help you to visualize and measure this. So this is what you can see, a data drift report. We're comparing the distribution of the training data with the scoring data. And if it is different, we'll tell you data drift is happening. Please take a look at it. So this is monitoring. Beyond serving the model, you also need to know the status of the model and whether they are making good enough predictions. All this would be automated, or all this need to be automated for you to really use this model in action. What is more is that now we have all these performance metrics under our watch. We will need to retrain the model. Remember what I said in the beginning, no model works forever. If the data start to drift, if the accuracy start to drop, you may want to retrain the model. It means that you may either want to schedule a monthly autopilot to continuously retrain the model, or you want to trigger the retraining by certain criteria. Let's say in this one, it means that when drift happens, when the drift score exceeds certain threshold, I will want to retrain the model. So this is like someone help you to take care of the model in operation, right? You don't have to watch the performance by yourself. You only need to set up the rules so that the model would be retrained and kept at a high standard. So come back to what I said about AutoML in the beginning. We're trying to remove the hurdle in the technical side of things to help you to focus on the business side of things. So what you need to be aware is that what is an acceptable range of accuracy? What are the frequency of data get refreshed? So you may want to retrain the model based on drift or based on performance. So all these are actually your business decisions and business insights. If you focus on this kind of business insights and decisions, the AutoML platform can take care of the rest and help you to retrain the model. So this is how an AutoML platform like DataRobot can help you with model deployment. The next part are the different scenarios of model deployment you may have in reality. So maybe if you haven't really built any model into production, maybe these kind of scenarios are new to you, but these are the scenarios we have faced in all kind of our client. So what I want to say here is that no solution is one fit for all. AutoML as a solution to machine learning to our enterprise user need to be flexible enough to address different scenarios. So in this case, we can look at least 6 scenarios of deployment. The first one is you have this model development platform. So you develop the model on this platform and you deploy it on this platform. This is what I showed you just now, right? Within one click, you can deploy the model in the same environment. I also showed you just now, you can select a different environment to deploy the model. So for the model you trained on this platform, you may want to deploy it in other environment. So you have the opportunity to do that. The next one will be more tricky. You may build the model elsewhere. So just now we were talking about the more experienced data scientists, right? Maybe some of them want to build the model using Python or R code. However, like me, they don't have the capability to move this model into production. So what happens is that they will have this customized model built outside the platform, but they want to bring it in to be monitored and served in DataRobot or in the AutoML platform. So the platform need to also address this kind of needs. We need to make sure a model built outside the platform can still be served, monitored, and retrained in this platform. Also, this applies to other environments, right? Let's say if someone built a model outside the platform and they want to deploy it in other environments, it means that they don't need the platform to serve the model. However, they will need the platform to monitor and retrain the model. So we'll also provide this kind of service. So you can imagine in the background, all these services are actually modularized. You can take some part of it to use it, and you can use the rest elsewhere. So this one is you build the model outside the platform, you deploy the model outside the platform, but you use our platform to monitor and retrain the model. And this is more complex. You may want to have multiple environments. This is actually quite common in the mature enterprise machine learning teams. They may want to have an experiment environment to keep on trying different new ideas. Once they get a good performance model, they will move the model into a production environment to be operated. So even for the same model, multiple environments may be involved. In this case, it can be used DataRobot to run the experiment. They use DataRobot as an experiment environment, but the production environment can be outside DataRobot. So this has to be supported as well, because people may want to switch in the environment, but they want to make sure the model performance is constant. That means that we need to have constant performance metrics across all this environment and help them to measure. And eventually, I think this is a rarer situation where you want to do everything outside and even offline, but you still want some platform to help you monitor the model or retrain the model. So we call this external deployment. So these are some cases. Maybe there are 2 cases in practice it is needed. First of all, it can be the model need to be deployed in some environment where internet access is not available. So we used to serve the client in Indonesia, and they have like the forestry management. Some of the model need to be run in an environment that is not accessible to, have no access to internet because it's so far away in the woods. We need to deploy the model in an isolated environment or a portable server. But once this server is brought back and connect to internet, we want to grab the performance metrics from the remote server and make sure the model is performing well. Another example is that if it is a very restrictive environment that does not allow any like internet access or external environment, in some of the banks, they do not allow any like external system to connect to their data system. So what we need to do is we need to put the model inside their system and put a small agent to monitor the model. And when they trigger the service, they will pass the information out, and they can see on the dashboard what is the model performance. So what I'm saying here is that when we talk about AutoML, it is not only about how do you build the model. If you want to provide AutoML as an enterprise level solution, you need to consider all these scenarios and be sure that all this can be addressed. Again, this is the reason why AutoML, although we have like open source packages, anyone can develop some automated model tuning. But to make it an end-to-end process, to make it covers all the angles of machine learning, you need an enterprise software, a platform to help you to address all these kind of different scenarios and needs. So this part may be a little bit technical. If you don't really have the experience of deploying a model, maybe it does not really echoes to you. But I think if you can foresee, like in the future, if you want to deploy a model, you may have all these kind of options, and you want the platform to be able to address each of them. Okay, besides this, we talked about how do we get the data, how do we build a model, how do we connect the model into production. But all this is not eventually someone who uses the model, right? We would want someone to use the model, who use the model to have access as well. So eventually, it might be an application for the end user. So let me show you an application that I have created in this. So this is a very simple and maybe ugly dashboard. So we have some description to the data itself, and we have the predictions. You can actually, here you can select some file. Let's say if you have generated a new file and you want to get new prediction, you can choose it from here. And then your prediction will be shown down here. If I go into this one, you can see there are several parts of it. If we look at this part, it's actually a prediction explanation. So, sorry. I'm leveraging the visualization here to show to you why are we predicting this to be a 80% fail, and what are the factors drive this value higher or lower. So in this one, we have several factors that increase the probability of the part to be failed, and some to decrease the probability. If I switch to the next record, you can see all this changed. So this is on record level. How do we explain the prediction? So this would be something useful for the user, right? If for the end user may not want to understand whether you use decision tree or XGBoost or neural network to build the prediction, but he or she may want to understand why are we making this prediction, why it is higher or lower. So this kind of distribution and the visualization help them to understand why the model is making such a prediction and why we're making the high or low prediction. Moreover, what they want to do is they want to create a record, right? So what they can do is they can actually key in all the value of certain measurement. So if this is in a manufacturing side, immediately they can key in all these values that from the front line and make the prediction right away. So here you can see we have already made the prediction on the right-hand side. This is actually the prediction we make for this input I just shared. There are other data points because I configured this as an optimization application. So not only data robot or the platform itself is making the prediction based on the input, it is also trying to find the best combination of input that minimize the value. So you can see here we have an optimal value shown here. It is created by alternating some of these variables to minimize the target variable. So in this case, it means that if we can change some of the input to this data point, we can actually minimize the target variable to a degree. This helps you not only to simulate the what-if scenario, but to optimize what is the best way to set up the parameters, right? If it is a churn problem, basically we can tell you what need to be changed. Maybe we need to encourage the user to use more data, to deposit more money, or to involve in different kind of initiatives to really stay with the company. So all these are the optimization and what if analysis you need to do. So you can see how far we take the automation on. Oh, by the way, this application is created purely by drag and drop. So no code needed still. You can actually create this just by selecting different components and build it here. You can even build it either as a web-based tool or a mobile-based tool. So this is something that we feel could be relevant to the business user as well. Again, reinforce my point about AutoML. It is not really about just no code or no math. It is removing all the technical hurdles for anyone who want to use AI, machine learning in their decision-making process. So this goes beyond how do we generate the model, how do we tune the parameter. It also includes how do we bring a model into production, and how do we make sure the end user have access to this model and are able to use it. So I think all in all, the AutoML, the value of AutoML creates is based on speed. So there are three types of speed that automation can help you. The first part, noted by Wang here, is the initial uplift of accuracy. I'm not saying that eventually the AutoML model will always perform better than any manual model. I have cases where I see the manual tuned model can even have a higher performance. However, I cannot beat the speed of automation. The automated model can give you the first cut result in a matter of hours, while I will need to spend days to wrangle the data, write down the first draft of the algorithm, and execute on myself. And not to mention, I cannot really compare the same model across 58 or hundreds of other models. So the first speed gain is the initial accuracy. You can actually have a high accuracy of your model within a shorter time with automated machine learning. The second or the third part of it is when your model start to operate and downgrade over time. No model works forever. When your legacy model start to downgrade, you need to observe the difference and rebuild the model again. If this is not automated, it will be much slower than an automatically monitored and retrained model. So the second gap would be here. When your model start to downgrade, automation help you to recover much faster. And the third speed gain, or the second point here, maybe I should resequence this, is the experiments and the use cases. If any of you are actually works in a machine learning team, I think you will agree that a lot of your model stopped as a pilot. I think in best case, if half of your pilot use case can be translated into production, that is already an outstanding result. So you will always develop some pilot that doesn't work, some use cases, some POC that doesn't work. If you do it without automation, it means that you may be able to deliver 2 or 3 use cases per quarter. That is already very good, because at maximum every quarter you can have 5 or even 10 POCs, and only 2 or 3 of them get accepted by the business user and translated into production. With automation, I'm not saying that the rate of acceptance would be definitely higher. It can be higher because we can involve the business user in the model development. But at least you can have a much higher base number. If you can do 10 use cases in a quarter without automation, I believe you can easily do 20 to 30 in a quarter with automation. It means that you can also triple or double your number of successfully executed use cases then. And that is the value you can create with automation. The amount of the model you can put into production, you can put beyond POC would be the value created by the speed. So this is where I see automated machine learning really add value to you or to any of the business, the machine learning teams. So this is what I see automated AI platform. I said that it need to take data from all these kind of sources. It need to address the business needs of all these kind of applications. It need to operate on different infrastructures. And inside here, we need to accelerate the experiment as well as take care of the prediction. So all this forms a modern AutoML platform for you to democratize AI. So it is not a trivial topic saying that AutoML is just auto-tuning or selecting algorithm. No, it's actually a much more complex platform engineering work need to be done in the backend for you to be able to be flexible yet robust in developing models. And before I end and before I switch to like Q&A, I think it is my 3 questions to you to reflect. Do you really need an AutoML platform, or does automation really can help you? First of all, do you have enough data scientists and enough data engineers and enough machine learning engineers to deliver whatever you want to deliver? In most of my cases, if I ask any chief data scientist or chief technology officer, there is a huge backlog in all their pipeline because they feel like there's a big gap of the data scientist, the data engineer, and the machine learning engineering sources. So they have to pass some of the work to automated platform to fill in this gap. That's how AutoML platform can help. Second, is your machine learning, data science, or AI team considered to be a cost center or an innovation hub? If I ask this question to any of your chief data scientist or CTO, the inspiration is always an innovation hub. The reality is always a cost center, because machine learning model, if it is too slow, you cannot just address the business value that you want from them. Even in the most advanced organization, machine learning team can easily be a cost center if they cannot clear their backlog fast enough. So the speed matters for them to build different use cases and prove that they can actually build innovative cases. And also, if the data scientists need to spend all their time in coding, in tuning the model, in make sure the environment and the performance is tally in experiment and in production, I don't think they will have much bandwidth to innovate. So the automated task is actually to free up their time to focus on more interesting tasks, to be innovative and solve more interesting machine learning problems. And finally, is there tech debts piling up in your organization and distracting your team from more interesting tasks? So tech debts is like the legacy system you use or legacy code you have. So I have seen one model in one of my clients. The model is actually built 7 years ago, but no one dared to touch it because no one really fully understands that model. And it is still working, so they cannot change anything out of it. So this is a tech debt. You are using 7-year-old technology to solve a new problem. It is because it is not standardized. It is not well documented. So only if you use a standardized way to tackle this problem, the next generation of data scientists or whoever hand it over to are able to solve it continuously and resolve this kind of tech debts. So if you want to standardize your approach to the different problem. I think using a platform would be an easier way, because you don't have to set up the rules. If everyone uses a platform, the platform is your standard, and everyone can be aligned to that standard. So this help you to ease the tech debts as well. So if any of the question, your answer is yes, please consider to use automated ML, to consider any like AutoML platform in your operation, in your machine learning building. I believe that it will create tremendous value to you. Okay, so that would be my presentation today. I don't see any question in the chat yet, but feel free to drop more questions now, or even like unmute and ask me questions. I'm happy to make this more of a discussion in the next 15 minutes.
Well, Dean, I must say that was a very detailed, prescriptive, and I should say I have learned an entire new world on using this automated platform, which I think before this webinar or this sharing from you, right, I didn't even realize there was this thing that we can actually adopt and use. I mean, seriously, I'm totally blown away. Thank you for sharing a lot of those details, because I think that would actually help a lot of our audience to shortcut some of their current practices when we get into that the ML learning using that platform. Like you said, I think that's something that we may not have considered to standardize the model, right? Because I take your point, because things are changing so fast. We are seriously lacking in data scientists, data engineers, machine learning engineers as well. Hopefully with your suggestion with Data Robot as well, I think that can actually help our audience or even some of our organizations out there to really shortcut what they can to really be one step ahead of their competitor. Is there any question? Let me just quick check again. Any question in the chat itself? Seems to be all good. I mean, thanks for answering that. Since there are no questions, Dean, again, on behalf of Enterprise Big Data, we want to thank you again for really coming on, for sharing a lot of those thought leadership. Like I said, I've learned a lot myself, and actually got me excited to say, hey, maybe I should check it out and give it a try. Dean.
We do have free trial. I don't want to make this too much like a commercial advertisement, but we do have free trial. So check out our website and feel free to try. Also, feel free to connect with me on LinkedIn or like reach out to me if you are interested. Definitely.
I think the rest of the audience, I think since Dean mentioned that there is a free trial, I think do check out the Data Robot website, and let's see if you can give it a go. And hopefully, like I said, it will really shortcut your progress on this machine learning. I think that's what we're here to so-called to do, to try and learn from the best practices that Dean have shared. Again, Dean, thank you so much for joining us for today. We're really honored to have you to share all those technical knowledge. Like I said, that's something that I think will be valuable. All right. Thanks, Dean.
Thank you. Thank you for having me here. I had a lot of fun, and I look forward to stay in touch and let me know if there's anything I can help.
So we hope to see you again in perhaps in our next year's so-called event as well. By the way, for the rest of the audience, we do have an upcoming track 1 and track 2. Track 1, it will be Muhammad, who will be talking about big data and AI architecture. And Saifullah will be talking about how big data can actually assist in understanding the human intention. Again, Dean, thank you so much. Really, really love the discussion and the sharing. We'll hope it will also benefit our audience as well. Thank you, Dean.
Thank you. Bye.
Bye. Have a good one.